Good morning and welcome back to the geometry class. And I guess I shouldn't assume that it's morning where you are. It's morning here in East Tennessee. Very lovely day. We are still in the polygons section of the course. So I'm going to go to that module. And just to remind you of all the things that we have covered, we've covered a lot of ground. So hopefully you are enjoying this course. I'm enjoying working with you on it. So I hope it isn't too overwhelming. I know there's a lot of new vocabulary and that can be difficult, but just hang in there. Call me if you need me and you'll make it just fine. So in this this video, I want to talk with you about triangles. And we've already touched on this a little bit. We talked about the definition of a triangle and what makes a triangle, sort of the anatomy or the DNA of a triangle. But in this video, I want to show you the formulas that you'll use to work with triangles, to get perimeters and areas in geometry problems. So we're going to start with the perimeter of a triangle. And I have figured out by watching my own videos to edit them that I'm zooming in and out way too much. So I'm going to try to curb that temptation to zoom in every time. I'll make the screen as big as I can, but I won't be zooming in and out so much because that's, at least to me, is distracting as a watcher. So I apologize for that up to this point. Okay, the perimeter of a triangle. Remember, perimeter means the measure around a shape, a polygon. So we're going to take this particular triangle and look at its perimeter. And the formula for this is pretty straightforward. It is perimeter equals side 1 plus side 2 plus side 3. Perimeter always involves addition. So in this case, we're simply adding up the sides of this triangle. So if you write this algebraically, you could let any one of these sides be side 1. I just over the years have developed the habit of using this segment for side 1. So there's 8. And then this segment for side 2, another 8. And then the base for me is always the last one. But since you're adding there, it doesn't matter how you put those in order. So you're going to add up the sides and you come up with 22 units for your perimeter. And I just want to call your attention to some vocabulary here. You notice that I have written the word leg for 2 of these sides. It would be this one and this one. Those are the legs of the triangle. And then on the bottom is the base. That's just something that we will use in the next formula. And also, really, anytime you work with triangles, you need to know which are the legs and which is the base. So those are just some review of vocabulary. Okay, let's look at the area formula for a triangle. And the area formula is quite a bit more complicated, okay? And I want to show you a little bit of where this comes from. This is called the derivation, or where this derives from. And to show you this, I want to first draw a rectangle. And this is just a little bit of theory. It really doesn't, it's not something I have to show you, but it's worth looking at. So consider with me a rectangle. Let's make it maybe 6 tall, and you can do this also. Okay, and come over here and do this. Okay. So on this rectangle, let's go ahead and count the units so we can get our dimensions. So the base of the rectangle, which is also the length of it, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units that way. And it is 6 units tall. Okay, so here's the height, which is also the width. So this particular rectangle is 11 by 6. And I know that I can find the area of a rectangle by multiplying length times width. So we would be saying 11 times 6 is 66 square units for this rectangle. So what if I brought another line down through here? Let's connect on the diagonal right there. Do you see that I have just created 2 triangles? I've just split that rectangle in half, and I have created 2 triangles. Let me color one of those in for you. I won't color them both because I know that takes some time. But let's color this bottom one in so that we're focusing on what I want you to see here. And I'm going to show you where the formula comes from for the area of a triangle. Hopefully it will help you to understand a little bit of the theory behind this concept. So there's a triangle. There's another one up there that I won't color. But here's the formula for area of a triangle. And see if this makes sense to you. Area of a triangle is 1/2 the base times the height. Now think about that just a minute. We used length and width because that's the proper thing for a rectangle, but that's also base and height. If you look at this base on this yellow section, we have 11, that's the base, and this height is 6. So this much is what we already know, the area of the rectangle itself. And then all we're doing with this 1/2 is dividing our rectangle into 2 triangles. So the area of this yellow triangle is 1/2 times 66, or 36 square units. Every time you do an area of a triangle, you will have to deal with the fraction 1/2 because we're essentially cutting a rectangle into 2 parts. Okay, I hope I didn't confuse you with that. I went through it kind of quickly, but let's find the area of this triangle over here. Again, you have 8, 8, and 6 as your dimensions. But the problem with this one is that we need the height because the area formula requires the height. And it's tempting to use the 8. I'm trying to push this back up on the line like it should be. It's very tempting to say that this triangle is 8 units tall, but that's a leg. That's not its height. So we together need to figure out the height. We need to figure out this dimension in here. And in this particular case, we can just count because it's not exactly to scale, but it's close. It's close enough that we can estimate. So let's count the blocks. We have from here, there's 1, 2, 3, 4, 5, 6, 7. So we're going to estimate the height as 7 units. And then write your formula. Area equals 1/2 the base times the height. So the 1/2 is cutting away that other triangle that I can't see in a rectangle. The base is 6, and the height, be so careful, I almost wrote 8 even though I know better. The height is 7 here. You can put all of this in your calculator. You've got 1/2, and I'm going to do that too. 1 ABC2 times 6 times 7 equals 21 square units for this area. So you can see that this little triangle over here, the one I have not colored, is quite a bit smaller than the yellow one. They're different kinds of triangles. This yellow one is a right triangle, and this smaller one is an isosceles acute, but it is a much smaller area than the yellow one. So you now know how to do perimeter and area of a triangle, and we are up to a skill builder. And that's exactly what we need to do on this one, is to find the perimeter and the area of the triangle. And I recommend that you stop the video and go ahead and try this on your own. If you need help with it, you can certainly start the video back up. But I would use this sort of as a test question to see how well you can do this skill without my help. So if you want to pause your video, and then when you're ready to check, restart the video, and I'll show you how to work these problems. Okay, I'm going to start with the thing that is probably most important here, and that is to find the missing dimensions. We do not know a number value for this dimension right there. And it's not exactly on the line, so we're just going to have to guesstimate this a little bit. I didn't do a very good job of drawing this one, so it's a hair over the line. But if you count these units, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to use a base of 10. It's really more like 10.25, so if you want to be very exact, that's fine. The height, again, I'm going to have to count, so that's 1, 2, 3, 4, 5 blocks tall at that top peak point. So the height is from there to there. So now that I know all of the dimensions, and please notice this is a scaling triangle. All three sides are different. The 5.5 and the 6.5 are not equal. So please be careful with that. Okay, perimeter first. So perimeter is side 1 plus side 2 plus side 3. And if you're doing a perimeter, you are not allowed to go inside the shape. Perimeter is an outside dimension. So we're looking at this side, the three sides of the triangle. And all three of those will give us the perimeter. We have to close the shape, so it takes 3 segments to do that. So side 1, and again the order does not matter here because you're adding. You're just getting a total, so you can put them in any order you want. Please be careful with the decimals because those are sometimes problematic when you type in a hurry. But we're looking for a perimeter of 22 units. So if I were going to walk this yellow perimeter, I would be walking 22 units. Okay, the area formula is a little more complicated because remember it will always involve the fraction 1/2. So area is 1/2, and I'm putting a pocket for base and a pocket for height. And the base is 10, the height is 5. Okay. Remember, area is inside, so we don't need the 5.5 and the 6.5. Those are different dimensions. We need the base and we need the height, and we need a calculator. So you can do 1/2 times 10 times 5, and you will get 25 square units for this area problem. Okay, I will see you in the next problem for an explanation of the Pythagorean theorem, which is also a triangle problem. It is a little bit long, so I'm going to let that video be separate, and I will talk with you soon.